So this is an explanation of how to find the length of belt as a function of phi. So I think this is the Greek letter phi. Okay, so if this angle here is phi, that means that this angle over here is also phi because they're alternate interior angle. They're vertical angles, excuse me. So those two angles are going to be equal, so that's also phi. So that should be helpful. They're also assuming these are all similar triangles, so that means this is also phi and this is also phi. So all those angles are going to be phi. The first thing I'm going to look at is the round part of the belt. So here's the belt, the round part of the belt, and here's another round part of the belt right here. And if you wanted to see the full belt, there's also the belt going this way all the way here, and then so the belt is going around both pulleys, okay? But we're going to focus on the blue part first. So this is almost all of the circumference. It's basically the circumference of the circle, but only part of it. So I'm going to say for this blue part, that's going to be 2 pi r, so that's the circumference, but only the part of the circumference that falls under. So times whatever that angle is over 2 pi. So only the portion of the circle that the pulley is kind of going around. So that part, okay? So I'm looking for that angle right there. Well, they told us that this is phi over here. And if that's phi, well, these three angles have to add up to 180 because it's a triangle. So if I can just erase that little spot there. So because this is a right triangle, and a right triangle has a 90-degree angle, and then a phi angle, that last angle has to add up to 180. So then to find that last angle, I'm going to subtract 90 and subtract phi from both sides. And that means my angle that I'm looking for, this question mark angle over here, in this particular triangle, if I just redraw that again, to be clear, this is phi over here. This is the angle I'm looking for. This is 90 degrees. It's in a triangle. So 90 plus phi plus this question mark equals 180. Subtract 90 and minus phi on both sides. My angle is going to end up being 180 minus 90 minus phi. Combine that. What do you get? 90 minus phi. So my mystery angle is 90 minus phi. So this angle right here is 90 minus phi. There's two of them because this central angle is also 90 minus phi. So that means that this leftover piece right here is going to be whatever is left over after I take out both of those angles. So I'm now going to change those 90 degrees to radians. So you should know 90 degrees is pi over 2. Since this is also in pi, this is also pi over 2 minus phi. This is pi over 2 minus phi. And I'll just make sure that we kind of notate that here. Where's that pi over 2 coming from? Because pi over 2 is the same thing as 90 degrees, but we just changed it to radians. Okay. All right. So because the whole circle has 2 pi radians, to find out the leftover, this part of the circle, we are going to do 2 pi minus both of those angles, which is pi over 2 minus theta, and there's two of them. Excuse me, not theta phi. So I'm going to subtract 2 of those. I'm going to distribute this 2, and so go ahead and simplify that and see if you can find out what it is. You can pause the video and try it by yourself. That cancels out. You get minus pi. And then I also multiply that by 2, so it's minus 2 phi. 2 pi minus pi is 1 pi minus 2 phi. So the angle here was this, pi minus 2 phi. So that's the angle. So it's going to be 2 pi r times phi minus 2 phi all over 2 pi. That cancels out, that cancels out. It's going to be the radius. Now the radius of the smaller triangle I should have marked in there. The smaller circle has a radius of 10 and the bigger one has a radius of 20. Okay, and it's centimeters. So the smaller circle's radius is 10, so I put 10 for the r, value of r, times pi minus 2 phi. So the length of the belt is going to be, so far, I put it at the very bottom here. If I distribute that, 10 pi minus 20 phi. I'm going to do the same thing for the other circle, so the green part, and this should, this you can pause the video and see if you can try that by yourself, because again, it's going to be the same thing but with a different radius. So I'm looking for this part of the circle. Because this triangle here has 180 degrees, if I take 180 minus 90, let's actually do it exactly like the other one. So if I draw this out, that was a 90-degree angle. This was a phi in the middle. If I draw this out and I'm looking for that question mark, well, this plus this plus this have to all equal 180. So it's going to be 90 plus the phi angle plus the question mark angle, which is the one we're looking for, equals 180 degrees. Let's even do this in radians to get a good practice in radians. So 90 degrees is pi over 2, and 180 degrees is pi. So I'm going to subtract pi over 2 and phi from both sides to solve for my question mark angle. Cancel that out, cancel that out. Pi minus pi over 2 is pi over 2 minus phi. So my question mark angle for the green is still the same thing. It's still pi over 2 minus phi. And the other one is also going to be pi over 2 minus phi. So if they're both pi over 2 minus phi, we're going to subtract both of them from the entire circle, which has 2 pi. So 2 pi. So the angle I'm looking for is going to equal 2 pi minus pi over 2 minus phi times 2. So go ahead and simplify that again. See if you get the same answer. I'm going to distribute. That's going to end up being pi plus 2 phi. Let me just make sure I got that right here. Pi over 2 minus theta. So when I distributed it, this should have been plus, excuse me. So let's fix that. This should also be plus. This should also be plus. So 10 pi plus 25. All right, so here we're going to do 2 pi minus 1 pi. So the angle I'm looking for is pi plus 2 phi again. And again, pi plus 2 phi is this angle right here. So I found this angle right here in the central angle. And that tells me what proportion of the circle I want the circumference for. So my portion of this circle is going to be 2 pi r, the entire circumference, times my angle, which is pi plus 2 phi, all over 2 pi. This cancels with this cancels with this. My radius for the bigger circle is 20 times pi plus 2 phi, which equals 20 pi plus 40 phi. So that's going to be plus 20 pi plus 40 phi. Okay. All right. So I'm going to just clean this up so we have space to work later. Combine like terms. 10 pi plus 20 pi is 30 pi. 25 plus 40 phi is 60 phi, or phi. Okay. All right, so that is the circumference part, the curvy part. We also want this part of the belt. All right, so let's start with just this this part. So this part right here, both of those red, and then we'll also add on later this. Okay, so let's do the red part. We're looking for this red here part here, which is part of a triangle. So I can actually draw that triangle on a new page. And I just want to point out this triangle here has a 90-degree angle, and it has a 10. It has a side that is 10 right here. So this side is 10. This side I don't know. That's the side I want to know, right? Because that's the belt. And then this side is the hypotenuse. And then this angle is phi right there. So just keep that in mind, because I'm going to just copy that over on a different piece of paper. Okay. So 90-degree angle, phi angle, and 10. So this was a 90-degree angle, this was phi, and this length was 10. So I want this because this is the belt right here. So I'm going to call that x. I don't know x, but I do know a trig function that uses opposite over adjacent, and that's tangent. So that means the tangent of phi equals 10 over x. I'm going to solve for x by multiplying both sides of this equation by x. This cancels out. I get x tan phi equals 10 divided by tan phi divided by tan phi. X equals 10 over tan phi. So that means the length of the belt here is x is 10 over 10 phi, but there's two of them. So that's going to be 10 over 10 phi times 2. Remember, 2 is the same thing as 2 over 1. So that's going to be 20 over tan phi. So I'm going to add that to my equation. So I found this over here, and this right over here was 20 over 10 phi. I'm going to erase this so we have some space here. Excuse me, let me actually fix this out a little bit. It's 20 over tan phi, but I don't want this to look so messy. So remember that 20 divided by tan phi is the same thing as 20 cosine phi. Excuse me, cotangent. So we're going to use it as cotangent. And that way we can add 20 cotangent phi and get rid of the angle, the division of the angle. All right, so then let's go back to this one and take a look at the last part of the problem. So the belt also includes this piece right here. So I want the length of this piece. Well, this is also part of a right triangle. Notice that in this right triangle, this side is 20 because that's the radius. And then there's the hypotenuse, and then this angle is phi, and there's a 90-degree angle there. So we're going to make use of that information. I'm going to draw this right triangle. Phi is here. This is 20. That's the radius in the circle. And we're looking for this because that's the length of the pulley belt. So it's this one right here. Okay. All right, so I'm looking for that length. And it's still going to use tan because tan of phi is going to equal 20 opposite over adjacent. Multiply both sides by y. That cancels. Y tan phi equals 20. Divide both sides by tan phi. Y equals 20 over tan phi. Remember, dividing by tan is the same thing as multiplying by cosine, so that is cotan, excuse me, again, it's cotangent, 20 times cotangent phi. And then there are two of them, so it's going to end up being 40. So remember that there are two of these, because there's one here and here. So 20 times 2 is 40 cotan phi. So I add like terms, 20 plus 40, that's going to be 60 cotan phi. So the length of the belt is going to be that.